In this video, we will look at the question, which equation corresponds to the points given in the table? We are given options to choose from: A, y equals 3 minus x, B, y equals 2x plus 4, C, y equals x plus 3, or D, y equals 3x. We will also answer a few follow-up questions. Does the graph of the equation pass through the origin? At which point does the graph of the equation cross the x-axis? And at which point does the graph of the equation cross the y-axis? Let's look at the first part here. And we're going to go through each one of these equations, and we're just going to be plugging in our x and y coordinates to see if any one of these pairings, or really all of these pairings, works in each equation. Now, to plug each set of values into every single equation would take quite a while. So for this problem, the most efficient approach is to use process of elimination. So we're going to try one point first with each equation and see if we can eliminate any options. I have chosen the point 0, 3 from right here because when you plug in a 0, it's very easy to evaluate, so I often like to use 0 when I can. So let's now start replacing the x and y coordinates in each one of these equations one by one and see if we can throw out any possibilities. With equation A, we have y equals 3 minus x. So we will replace the y with 3 and replace the x with 0, and then simplify and check if our statement that results is true or false. All right, now this one is true clearly because 3 does equal 3. So A is a possible answer. Now there's only going to be one correct answer, but you shouldn't assume that the first one that gets a win is going to be your answer, because it's possible that this point works with this equation, but maybe some of the other points wouldn't work. Also, it could be true that one of these other equations could work with that. So let's keep going. B, y equals 2x plus 4. Again, we replace the y with 3, we replace the x with 0, and simplify. 2 times 0 is 0. 0 plus 4 is 4. So we get a resulting statement, 3 equals 4, which is false. So we can eliminate B from our possible answers. Next, we look at C, y equals 3 plus x. We replace our values again and simplify, and we get a true statement. So C might also be the correct answer. Let's look at option D. Plugging in the coordinates y equals 3 and x equals 0. Then simplifying, we know 3 times 0 is 0, so we get a false statement, 3 equals 0. So we can eliminate D also from our list of possibilities. So now that we have only 2 options that could be correct left, let's pick another point and use it to see if we can eliminate one of those. Now I mentioned before that it's convenient to pick a point that has a 0 coordinate, so you could choose to pick 3, 0. But this time I decided to use 1, 2. Certainly you don't have to ever just use points that have zeros in them. So let's try 1, 2 with each remaining option. So A, y equals 3 minus x, replace y with 2, replace x with 1, and simplify. 3 minus 1 is 2, so we get 2 equals 2, which is true. So most likely this is the correct answer because there can only be one. But we'll go ahead and check the second option, C, as well. So C is y equals x plus 3, replacing our y with 2 and our x with 1. 1 plus 3 is 4. When we simplify, we get a false statement. 2 is equal to 4 is certainly false. So again, we've eliminated C as an option and that leaves A as the only correct answer. Let's look at the follow-up questions now. We know which equation matches our coordinates, but we want to also know, does the graph of the equation pass through the origin? Now, we're going to look at the graph in a moment, but before we even do you know what the origin is? The origin is where both x and y equal 0 at the same time. So notice that here in my set of ordered pairs, when x equals 0, y does not. And similarly, when y equals 0, x does not. So we've already seen the coordinate pairs when each coordinate is equal to 0, they're never 0 at the same time. So I know that the answer is no, because 0, 0, which is the origin, is not on the graph of y equals 3 minus x, because when x equals 0, y equals 3, and reverse that also when y equals 0, x is equal to 3. But let's look at the graph for a moment. Okay, so here's my table of values, and I can start plotting these points. Negative 3, comma 6 is the first point coordinate set, and that means that x equals negative 3. So from the origin, 0, 0, I would move to the left to negative x equals negative 3. And then I also will go up 6 values to match up with y equals 6. And I get my point right there. Graphing negative 2, comma 5. Notice I went to negative 2 on the x-axis, and then I jumped up 5 units to the point coordinate negative 2, comma 5. And if we continue in this way, we'll see all of our points lining up as we go. All right, now notice that if we use the equation that we decided was the answer and graph that, it goes through all the points as it should. Also notice that the line does not go through the origin, which is down here. All right, so let's talk about the x-axis. At which point does the graph of the equation cross the x-axis? This has a special name. It's called the x-intercept. It means exactly what you read here, that the line crosses the x-axis at a certain place. Now we can think about this, but let's also look at the graph. All right, so there is our set of coordinates again with the line passing through them. And we were just asked where it crosses the x-axis. So here's my x-axis down here, the horizontal line axis. And notice that if I go right here, that point, which is 3, comma 0, is the x-intercept. Now, notice that y is equal to 0, because no matter where you go along this axis, y is always 0 because you don't move up or down from the starting point, the starting line, as far as y is concerned. So here are all my y values. And notice that right here, the y value is 0. So if I stay on this level horizontally, every single point along that line will have the y coordinate of 0. So what we can say is that the points on the x-axis always have a y coordinate of 0. So 3, comma 0 is the x-intercept of the line because it has y for 0. Now the next question asks, at which point does the graph of the equation cross the y-axis? Right? Almost the same question as this one, but instead of talking about the x-axis, we're talking about the y-axis. So what we're looking for is the y-intercept point. Now, if the y-coordinate is always 0 on the x-axis, then which coordinate is always 0 on the y-axis? If you're thinking that x would have to always be 0 on the y-axis, you are correct. So points on the y-axis always have a x-coordinate of 0. So looking in our table of ordered pairs, I look for the pair that has the x value of 0. Okay, so this set of coordinates, the ordered pair 0, 3 is the answer. That is the y-intercept of our line. Now let's take a look back at the graph and just confirm that we observed the line intersecting the y-axis. In other words, the y-axis is intercepting the line, which is why we call this the y-intercept at this point, 0, 3.